Okay, here's the second one of the series, and I'm going to give you 3 examples on chord-chord relationships out of chapter 11-6. And let's go ahead and get started. First of all, when we're doing with 2 chords, again, just as a refresher, chords are just basically, I like my purple. Yeah, I got purple. Chords right here are basically going from one side of the circle to the other. They're straight segments, and they're all inside the circle. So when you have this relationship, just real simple, and again, we're not going to get into the theories or the details why, but we're just going to have part times part. So part times part is equal to part times part. So we just simply set that up as 4x is equal to 6 times 8. So we got 48 is equal to 4x, okay? And that gives us x is equal to 12. That's our algebra answer. If I ask you to find your geometry answer, we just simply plug it in. So that's just going to be 16 there, and that's going to be 14 there. All right? And that kind of makes sense if it was drawn to scale. Very often, geometry teachers just throw these things together without thinking. But this one looks fairly drawn to scale, where this is going to be 14, and that's going to be 16 right there. All right? Okay, let's take a look at another example with a little bit more application to it. And we got Molokini and tiny little island. It's not as fun as Kuhulavi where you can actually blow up goats. But anyway, Molokini, we got 2.5 miles off the Maui coast, blah, blah, blah. So half the time I don't even read these word problems. I just actually go right to here and go, look at that. Well, I got myself a chord, and I kind of redrew it here, and this is what you'd want to do. And you want to divide it in 2. So 1150, so that's 500 plus 50 plus 40. So we're just going to divide it into 590 on each side, all right? 590, 590. And this guy right here is 225.4. We're going to call this x. All right, so it's the exact same thing. Part times part is equal to part times part. Well, when I write it out as an equation, there's no way I'm going to do this in my head. 225.4, that's a point, is equal to 590 squared, or 590 times 590. Okay? I'll go ahead and write it out like that. So I'm going to just go ahead and do x is equal to 590 times 590 divided by 225.4. So watch this. I can do 590 squared if I wanted to. Boom. Divided by 225.4. Knock it out, and x is 1544.4. So this right here is 1544.4-ish. We're rounding a little bit. When we round, we actually take off a little bit of slice right here. But that's just the nature of actual real-world problems. The diameter is these two things added together. So all I would do is just add plus 225.4, and we're done. 1769.77. So 1769.77. Next problem. All right. Part times part is equal to part times part. Find this part. They asked for the whole diameter. Next one. I just threw this on here just for a little bit more practice. Just to show you that we can get algebra and you could get quadratic. Say if this was a 2x, you would have some serious quadratic work to do. Part times part. So let's go ahead and do this. 2 times 2x minus 1. And this is just a little bit algebra practice. 3 times 10. All right. So we distribute 4x minus 2 is equal to 30. So we get 4x is equal to 32. My x is equal to 8. Algebra answer, yippee-yay, we know this one is 13. This one is going to be 16 minus 1, which will be 15. All right, so this one will be 15. Alrighty, that's pretty much it. I'll go ahead and produce the next one of the series, which I think is secant lines in circles. Alrighty.